We're going to find the radius of convergence and interval of convergence for the given series. We're going to use the ratio test and set our limit less than 1 because that's when it's convergent. So I'm going to go ahead and rewrite this as n to the power of 3/2, and we're going to take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. All right, and this is going to be your a sub n. So let's fill this out so we can get used to see what we have. All right, so absolute value, you take for negative 3 to the power of n plus 1 times x to the power of n plus 1 divided by, and again we're calling this n to the 3/2, so this is going to be n plus 1 to the power of 3/2. Now we're going to divide by a sub n, which is the same as multiplying by the reciprocal. So just flip these around. So this is going to be times n to the power of 3/2 divided by negative 3 to the nth power times x to the nth power. All right, now we're just left with simplifying. So let's see what we get. We get limit as n approaches infinity. When you simplify this, that's just going to be negative 3, the absolute value here. And when you simplify this, these two, that's just going to be x. And then we have both of these are to the 3/2 power, so we can write this as n divided by n plus 1 to the power of 3/2. All right, now absolute value of negative 3 is 3. And then I can pull out the x, write this the limit as n approaches infinity, and I can write this as 1 divided by 1 plus 1 divided by n to the power of 3/2. When you do this limit, this just equals 1. So we get 3 times absolute value of x. Now we want this to satisfy condition 1 of the ratio test. So we want that to be less than 1. Solving for absolute value of x, we get this as less than 1/3. So our radius of convergence is 1/3. That's that part. Now we have to find the interval of convergence. So we're going to let x equal negative 1/3 and x equals 1/3. And we're going to test the endpoints. So if we have x equals 1/3, then we have the series n equals 1 to infinity of negative 1 to the power of n divided by n to the power of 3/2, which converges by the alternating series test. Now, let's let x equal negative 1/3, and then we get the series n equals 1 to infinity of 1 divided by n to the power of 3/2. This is your p series, where p equals 3 divided by 2, which is greater than 1. So it also converges. So when you're looking at your endpoints for your interval of convergence, since they both converge, that's going to be closed interval negative 1/3 to 1/3. So all you're doing when you're testing for the interval of convergence is seeing, can it equal this? If it said divergent, say for this for 1/3, then it would just be open interval. That's all you're doing for the interval of convergence. All right. Thank you. Have a nice day. Bye-bye.